Okay, in this video, I'm going to aim to sort of quickly explain in detail, clearly, these two results. One is for the distribution of sample means, which shows that it follows a normal distribution when the random variables are normal. And one is the central limit theorem, which is the extension of that, which is for any distribution, the distribution of sample means follows the normal distribution provided that n, the number of samples, is greater than 30. So the first result states that when the random variable follows a normal distribution, we have some result for sample means. Okay, so first of all, let's define sample means. Sample mean is just take a sample of this population. So let's say there's 1 million data points here. 1 million people were surveyed or whatever to get these answers, to get this data. There's 1 million data points. I don't want to take 1 million data points. I want to take a sample. Let's say I take a sample of 10. So I randomly select 10 data points or people from this data set, and I find the mean of that data. Okay, so maybe I take 10 data points all from this corner. The mean of that set will be down in this corner, but that would be rare, right? It would be extremely rare for me to choose all 10 of my data points from this little area here. Most of the time, I'm going to get a spread, right? I'm going to choose one from here, one from here, one from here, one from here, one from here. It'll be spread out. And the mean of those spread out 10 values will be somewhere in the middle, right? Similarly, if I get all 10 values in the middle, which is fairly likely given that most of the data is in the middle. So if I take 10 randomly selected data points, they might all be in the middle. The mean of those would be in the middle. I might get them all here, then okay, the mean is here. I might take like 6 from this half and 4 from that half, and okay, my data is slightly skewed this way. But I will find that most of the means are gathering around the center, around a center, and it will look kind of like this. And we know what this looks like. That's a normal distribution. Most of the data is gathering around the center. Some are this way, and some are small, but not very many. This is a normal distribution, right? A normal distribution. Furthermore, the distribution of sample means distribution, the blue line, has the same mean as from the whole population, which also makes sense logically. Okay, so we get this. The distribution of sample means follows a normal distribution which still has the mean mu. But the standard deviation or the variance is getting smaller as we take more samples, which also kind of makes sense, right? If we take the mean of like some of these wide values, we'll get the middle. If we take the mean of like this here, we'll get this part, right? So the more means you take, the less deviated your data becomes. This is the result of a sample of means distribution. And from here, the central limit theorem is another step. Okay, so the central limit theorem states that for any distribution, not just for normal distribution like the earlier result, for any distribution, we get the distribution of sample means follows a normal distribution with mean mu and standard deviation this, provided n is above 30. Okay, it's the same answer, but this time it's the same formula, but this time it's for any distribution provided n is above 30. That's the difference. Okay, so let's try and think about this logically. I drew 3 distributions on the board, and it's 3 of the ones that we might think don't yield a normal distribution for the sample means. But let's try and think about it logically. here is a concave up distribution. This might arise if you survey people and you have those that are strongly disagree, don't know, agree, and strongly agree. This might arise if most people are strongly one way or strongly the other way, right? Now, if I take a randomly selected sample, if I get 5 from here and 5 from here to make up my 10, that's two extreme values, but the mean will be in the middle. The mean will be in the middle. If similarly, and that would be the most common occurrence, right? Because that's where most of the data is. If I got 4 here and 4 here and 2 here, the mean would be in the middle. And again, that's a large percentage of the samples that I would get. It would be a lot on this side, a lot on this side, and a little bit in the middle. So that's what data set is. If I got all 10 over here, it's possible. The mean will be here. If I got all 10 over here, the mean will be here. It's possible. It's not as likely though. If I got, I don't know, just a random thing, like 2 here, 2 here, 2 here, 2 here, 2 here, mean is in the middle again. And so we can kind of intuitively think, yes, this makes sense. The sample, the distribution of the sample means is following a normal distribution. Let's look at that one. This one is a uniform distribution. You can think of it like the chances that it's going to rain on any day in the same month. So you would expect the same weather on every single day, are roughly or almost exactly the same number of people voted on strongly agree, whatever. It's a uniform distribution. It stays the same. Okay, my most likely sample for this, if I select 10 people, would be like 2 here, 2 here, 2 here, 2 here, 2 here. Right? 2, 2, 2, 2. 2, 2, 2, 2, 2. 2 here, 2 here, 2 here, 2 here, 2 here. And the mean of those would be where? The middle. That would be my most likely thing to happen. Sure, similarly, it might be over here, it might be over here, but that would be less likely. It might be skewed, but yeah, less likely. But the most often occurring mean would be central. The most often occurring mean would be central. They would gather around a center point and form a normal distribution again. And you can logically think about this one. I'm not going to go through it. But the distribution of sample means forms a normal distribution. So this has to be somewhere in your notebook. Has to be. Similar, this has to be somewhere in your notebook. Linear transformations of random variables. And this has to be somewhere in your notebook. Linear combination of random variables. And that's the information for 13.6. Distribution of sample means central limit theorem.